For many years, I've wanted to learn how to design my own 3D printable parts. So I'm going to start with the most reasonable thing I can think of, designing a physical media creation command center. It turns out it's not quite as hard as I thought it would be. In this video, we'll go over the previous 3D printing setup that has served me well for a very long time, and take a look at a Creality K2 Combo I just picked up. I'll go step by step through how I learned to create simple L brackets all the way up to ridiculous things like this. You get a taste of 3D printing and it gets you drunk with power. So follow along on this 3D printing learning adventure and workshop upgrade video. We might even make a new friend along the way. Let's get into it. Down here in the workshop, I do most of my work and experimentation and debugging on the bench you see in front of you. For example, I'm gearing up with this Cisco Cache Engine 505. This thing has been a long time coming. I apologize, MX Shift. But a lot of important work happens just to the right. On this workbench, where I've got my main workstation and another little area. Until very recently, this area just collected stuff. About a week ago, it looked something like this. Are you even a YouTuber if you don't have one of these green mats? Something I use this area for very often is writing physical media. So you can see I've got this DVD CD burner right here. In practice, what that looks like is I hook up this SATA to USB adapter, then I plug it in over there, and then I've got this USB to SD card adapter. As I'm filming, I pull the SD card out of the camera, I put it in here, but when I'm burning discs, I pull that out, slows me down, I plug this thing in, and then hiding back in there is a Greaseweazle. A Greaseweazle lets me hook up a floppy drive and connect to my computer over there over USB-C and write floppy disk images. All sorts of different flexibility there. That's super useful. You'll see I have no floppy drive. Recently, I have been organizing everything down here, and somewhere in these bins, I've got one labeled floppies. In the floppy bin, I've got a floppy drive that I usually use with the Greaseweazle, and it's amazing to know where it is. Usually it just hides and runs around and I can never find it when I need it. So what happens is I'll hook up the Greaseweazle, I'll have to hook this thing up, and it all just kind of sits here like this and piles up with other gear, and it's no good. I put these shelves in a long time ago, and I always sort of had a dream that I would sort of have like a permanent setup for these things. I realized there are more practical ways to do this. This is just how I like to do it. Started thinking about it and thought that's a waste of space. What if they were mounted underneath like this permanently? The CD-ROM, obviously I could find a USB to DVD CD-ROM thing, but the floppy drive, it's really nice to have a real floppy drive hooked up to the Greaseweazle. So you can't knock me for this. Have that mounted right there. I think that would be sweet. But how can I mount that stuff? Well, of course I could find some prefabricated brackets, little L brackets, but I think this is the perfect excuse to learn how to design a part and 3D print it myself. Not only am I going to need some simple L brackets to get these onto the shelf, and we'll have to have some rubber bumpers for this one, I think, for vibration reasons, but they've also got some, stuff coming off the back. So this thing needs to plug in here. It'd be nice to eventually make it so that I could get this stuff out. I don't think I'm going to get that adventurous today. And then, of course, this needs somewhere to go. It would also be nice to be able to get this out of the equation whenever I wanted. So yeah, that's the plan. We're going to figure out how to mount this stuff under this shelf and design all the parts we need. I am hearing some noises I don't like upstairs. I'll be right back. I'm happy to report we have another cat. This is Jasper. He is 11 weeks old, and him and Chloe are getting along really well, and I'm pretty sure they just got into a plant because he's got dirt all over him. Say hello, Mr. Jasper. He's super nice. Him and Chloe are like best, but yeah, you have dirt all over you, dude. Anyway, he obviously isn't allowed down here the same way Chloe was. It took 6 months, maybe a year before I could let Chloe down here. He's pretty good though. He's pretty easygoing cat. Anyway, say goodbye, Jasper. Put you back upstairs with Chloe. You probably won't see Jasper again for a while. He's just too young to be down here with all the cables and everything. And in fact, it's going to cut into the Chloe content because the whole basement's locked up until Jasper learns what he's all about. I can assure you, though, they are best buds. This is the 3D printing setup I have been using for many years. And in fact, it's not even mine. It's a buddy of mine's. I have more space down here. So he set this up and bought it, I want to say, 5 years ago. It's a Creality Ender 3 something or other, and it has served me well, but a lot of things have changed in the last 5+ years, and I've always had this dream of being able to design and build my own objects to 3D print, and everyone says it's not that hard. I've done a fair amount of research. I think it is hard. They're gaslighting you. And I wouldn't say I'm very passionate about 3D printing. I just want to know how to do it. I just want it to work. I can figure out the software stuff, which is mostly the hard part, and I don't know how to do it yet. We'll learn that in this video. This thing needs like a lot of manual leveling. So my buddy leveled it and got it all set up, built it, brought it over here, and it worked perfectly for a couple years. Then over time, things get out of whack and you just got to do stuff, and it was really finicky, and I just knew I was going to be really pissed off trying to learn how to 3D print stuff on this one. So yeah, there's nothing wrong with this thing, and I think it was like, man, even 5 years ago, it was like $180 or something. And if you think about that in like 2021 money, not that bad. It's got an interesting design. So the bed goes back and forth like this. The print head can go left and right like that, and it can also go up and down. I'm probably not supposed to do this. I'm gonna take this back to my buddy, and we'll reset it up at his house and get it all dialed in for him. But yeah, this is not the one we're gonna use. This is the one we're gonna use. This is the new 3D printing setup down here in the workshop. A friend of mine, another friend of mine, who is a little more into 3D printing, he has a Creality K1, I want to say, and I was telling him, I just want something that's more or less gonna work. I'm not an idiot. I'm pretty technical, but I don't want to get into the nuts and bolts of it. I just want to send a print to the thing and have it work. And he said, buy the Creality K2 Combo. So that's what I did. And I like this thing a lot. I've been using this thing for about a week. It's got a touch screen to do everything with. It's enclosed, which I think is pretty common now, so that they can keep the temperature at the right temperature. In this one, I'll give you a zoom in later. The bed goes up and down, and the head goes left and right. It's only on 2 axes. So maybe that's a better, I don't know, style. I was saying the other Ender 3 setup was, quote, interesting, but I think that was just, a cheaper model and just how they did it back then. This seems better. An interesting aspect of this K2 combo, which I really like, is that you can load multiple different spools on it. Not that I would ever print multicolor, but it's nice to be able to just press a button when you send it to print from your phone or from your desktop. I'll show you that. And it just auto spools whatever color you want. I suspect I'll never do multicolor, but I might do multi-material someday. You lay down a base of something and then build on top of it. That was a little finicky to set up, I'll be honest, but once I kind of got the first spool going, it was okay. And then you can see the print head over here. It operates left, right, back, front. The bed comes up and down, and this thing gets ripping. It moves way faster than the Ender 3, and the whole bench was vibrating, and during my first print, I literally zip tied it to the other shelf to get this thing to stop moving so much. Hasn't been a problem though. So yeah, I'm pretty impressed. I'm not affiliated, of course, but this thing is pretty sweet. I think the basic first step is you literally draw what you want and get some dimensions. So I need some L brackets coming off this guy like that, so we can mount it under the shelf. Done some drawing here, so obviously we need the length and width of the L bracket, but the side that attaches to the CD-ROM has 2 screw holes, and I'm just going to use one larger one to the top of the bench. Let's decide this length. Got some calipers here in millimeter mode. I will be doing this in millimeters. I don't hate myself that much. I would say if it was 40, that would be fine. So this height, 40 millimeters. They were nice enough to give us lines for the exact spacing of the center points of the screw holes. I'm calling it 12 millimeters. As for width, I'm going to use one of these 1-inch wood screws to attach it to the bench. So I don't know, let's find a nice round millimeter number. Let's do 20. This thing takes M3 by 5 screws, according to the label, which is probably going to be a problem for us finding long enough ones. That hole is 2.3 millimeters. We'll start with that. I just messed around for about 30 minutes and I have designed and printed a part. This is an arbitrary L bracket I just created with 2 holes on one side, 1 hole on the other. Didn't do any of these measurements. I just wanted to see if I could literally create anything. This is looking promising. By complete coincidence, I accidentally made this test piece have the right sized hole for this particular screw. So I'll copy whatever I did there. I was looking at the schematic and it's 6 millimeters, but in reality, it only measures about 5.5 millimeters. So that might be interesting as we get into some more tolerances that actually matter. Also need to decide how long this is, and honestly, that looks fine. 20 millimeters if you're playing along at home. On the final brackets, I'll print 4 of them, and I will have a rubber bumper that the screw will go through, I think. I guess I don't have to do it that way. There's a million ways to do this. We're just going to try it this way first. And that will provide at least some damping, vibration damping for the DVD-ROM. I don't think we'll have to worry about that for the floppy drive. Alright, I think that's all our measurements. It's pretty nonsensical looking, but I know what it all means. Let's translate this into reality with some software. Here is the little test piece I just designed. Took me about 30 minutes. It is very hard to control this thing. Something that was hanging me up, I think, is I would watch a lot of YouTube videos, and you can get pretty sophisticated with how you would produce a part like this. And then I saw one that was like a guy just drawing lines. And that's more my speed, and that's how we're going to make our parts. I'll link to all the tutorial videos I used down in the description that got me this far. This is a tool called onshape. You can sign up for a free account. The caveat being, all your projects will be public. So like this little bracket I just made, I think people can search for whatever I called it, brackets, and they can use this. They can't edit your project. They can copy it and print it themselves and do whatever they want. That doesn't really bother me. This software seems pretty solid so far. We don't need to start a war here. There are many different CAD packages that can produce something like this. I just watched a video and it sounded like this one was going to work out for me, and it has so far. We are going to start from scratch. I definitely could just edit this one that I have here, and you can see I can change the spacing on everything, and I could extend the height and everything. But for the sake of me getting a little better at it and maybe teaching you a thing or two, let's start a fresh new project. You are presented with this perplexing thing, the 3 panes, the 3 axes of our 3D world. And the first thing you do is up in the left, you go create new sketch. And then I'm going to choose any of these panes, really, it doesn't matter. I'll choose front. And you can press N, and it'll point whatever you're working at you, which is pretty nice. And then control right click lets you move like this. One thing that can catch you up is wanting to press OK after you've created the sketch. But this panel here actually means we're editing aspects of the sketch. In the simple part we're making, at least, we're going to have sketches and extrusions. A sketch is 2D, so it's like what I drew on the paper, which I need. In this first sketch, I'm literally going to draw out the L bracket and we'll establish some dimensions. Then we'll use something called extrusion to make it 3D, so to speak. So what we're going to do is hit the line tool. There are many ways to do this. I could make a rectangle. I could put 2 rectangles together. This is what I'm going to do. Click, make my first leg. Then we'll go down. Dimensions don't matter at this point. I'm just getting the basic shape out of my L bracket, and we'll bring everything together. Looks like an L bracket to me. But now we need to establish all the dimensions. You do this with the dimension tool. Up here you can see it. You can press D to activate it. You click a line and drag out, and you can establish a dimension. In my case, this needs to be, I can't remember, 20 millimeters. Perfect. And you basically do a bunch of this. This one needed to be 40. You can see the part has grown. We have a problem now. I need to constrain this to a dimension. So I'll drag this out. By random choice, I made my thickness, so to speak, 4 millimeters, and that has resulted in an incredibly strong bracket. So we'll set that to 4, and we'll need one here, 4, and that's our part. Now, there's more to this. This is what's called fully constrained. So if you remember earlier, the lines were blue because it was ambiguous to the tool how big or long things were. Now it knows everything it needs to know about this part. And something that was really throwing me off in a lot of YouTube videos is there are better ways to do this. If you want to be more efficient at it and make a lot of tweaks, or you're dealing with a more complicated part. For example, there's ways to constrain this 4 millimeter and tell it this one is also 4 millimeters, and you kind of adjust them in the same area. But if you're just starting out, just draw some lines and give it all the numbers it needs. Now at this point, we are done with our sketch, and we'll click OK. And what we're going to do is select this whole thing, and you can see it's highlighted. Up here, we've got the extrude tool. Let's click that. Behind the scenes, that has taken our 2D thing, you can see it in orange there, and extruded it out. We're starting to get into the 3D world, and I need 20 millimeters according to my little diagram here. Something that can be nice, for reasons you'll see later, is I know I need my 2 screw holes in the middle of this thing, but it's coming off of one of these planes. And so in the extrude menu, I can tell it to be symmetric, and it will split the pane in half, and you will see later that that is desirable. I'm already noticing a mistake I made. So you have your part, you can kind of roll around. What's nice is you can double click on one of your sketches and it'll take you back to all the dimension stuff, and press N and it takes you in here. And I have made a mistake. Mine were actually 3 millimeters thick. I was just taking a look at the other project I made. Okay. And whenever you make a change to a sketch like this, you obviously click the green button, and then you're back in this mode where you're looking at the whole thing. Now, we need to put some holes in it. It's sort of odd, but it does get intuitive the more you do it, you know, in my 1 hour so far of experience. But if I want to put holes on the face of one of these things, I make a new sketch. So, new sketch. It's in like an error state. You select the thing you want to deal with. So I click that, and now I'm messing with this thing in sketch mode. And it won't come as much of a surprise, but there is a circle tool, center point tool. You click and drag, and we need 2 of them, so we'll click and drag. And then of course we need to put dimensions on these things. So D to get my dimension guy out. And this is the diameter, I believe 2.3 millimeters. I'm going to do the same thing to this. Note, to get the diameter, I clicked on the outer part of the circle there. And we're going to put that to 2.3. They're obviously in the wrong spot. I'm now realizing I did not measure where these need to be. We will go back to the bench shortly, but I do know that the center point of each of them needs to be 12 millimeters away. So I think what I can do is one of these guys. Yep, 12. Okay, so now at least I'm pretty sure if I move one of these, I don't know how to move one of these. Oh boy, it's falling apart. Oh, okay. Now they're constrained together, which is nice. There's a bunch of fancy ways to do that with a bunch of different aspects of the sketch. And you can see the obvious benefit here. When I make a change to one, the other one adjusts accordingly. Anyway, I don't know where they should be. Because the sketch knows that these are always 12 millimeters away, I don't actually care where this one is. I only care about the top distance from here to the first center point of that one. So let's see if we can figure that out. There are a lot of specialized tools to do stuff like this, and it is awakening something in me. I love buying tools. I think we can call that, it's probably 20. I think 20 is going to be good enough. Let's see if we can pull that off. This is a little confusing. This is actually the bottom screw here. You know what I mean? So from this edge right here to the center point of here, we want 20. Well, that's not too bad of a view. We'll see if we can pull that off. So I'll go into dimension mode. I'll click from here to here. Oh, that didn't work. Yes, it did. Okay. This is 20. Yeah, that side is done. So we will close our sketch as complete. Never mind. We didn't actually make holes. It's extrusion time. So we will choose extrude. And we're looking at, I think I could, no, that's not going to work. Round 2. Choose extrude. Then click the sketch we just did with the 2 holes. And you get this ridiculous thing. We want to send them the other way. So we'll say opposite direction. And then we'll select remove. And bam. We've got some holes. Now we could do another extrusion to sink the screw a little bit. I don't even think I have the screws I need to do this. Hopefully they're on the way from Amazon. Otherwise I'm going to Home Depot tomorrow. But that's going to be good enough, at least. I'm probably going to have to make like 3 of these before we get it right. That's good enough. Let's turn our attention to this guy. And so we're going to make another sketch. I'm going to choose this face. And it doesn't really matter where the circle is on this one. We can probably just put it roughly there. However, the dimension matters. Let me go consult the other part. It was 6 millimeters. And then we need to decide where it lives. There's probably a way to auto center it or whatever, but put it at 9. I think that looks good. And so same story. We'll close this sketch. We're going to extrude this thing, and you end up with these ridiculous looking parts, of course, but we know what to do. Remove it. Now we've got a hole. Close that out, and I think we can do one more sort of nicety. So up here we've got the fillet tool. So let's select that line and choose fillet, and we get a nice little curve. I'm thinking that's like, no, that's not too aggressive. I think that looks good. I think that looks good. This is our part. We did it. There's our bracket. Now the question is it gonna work? So right click here, do export, and you're gonna want to choose fine resolution. We are not in meters. I believe we are in millimeters. That's scary. My other one didn't do that. And I want the STL format for my Creality printer. Let's export that. Here's the Creality software that came with that printer. I've already linked it up to the printer. So if I go to device, it knows that the printer is over there and all the various PLAs it has and its spools at the top. So we're going to import that STL file we just created, and probably don't want to print it that way. How do I fix this? There used to be just like a simple rotate. Oh, there it is. Ooh. Auto. That is such a bad auto choice. I bet it could print that. Probably wouldn't be very good. Why don't they have like this is stupid. We're almost there, folks. I mean, I knew the value was 180. It's just weird that, anyway, I think that's going to be fine. Creality letting me down. So yeah, that's what it's going to look like on the plate. This is how I printed the other one, and it worked out pretty nice. These holes were not as quite as accurate, I think, because as it's printing up, it's got to like leave that gap. And then again, this one was a little off last time, but I think it's going to be fine. If the hole is smaller, that's no problem because you just drill it out. I'm not a perfectionist. This is my second 3D printed part. So let's send it to the printer. Actually, first we got to slice. So we're going to slice. This is how it's going to make that thing, which is fine. You can really get into this. This thing doesn't need any supporting structures. You can decide like how much filament it's going to use inside and all that. I don't think that's a big deal for us. Based on this thing is super strong. I'm shocked at how strong this is. I thought we were going to have to put some like supporting brackets and stuff, but I don't think that's going to be necessary in this case. Down here at the bottom, we're going to do send print, and it loaded up the camera for the printer. You can choose the spool at the top. Remember, I've got 4 of them. The 4th one is not populated. I guess we'll just keep making blue brackets. I don't really care what color they are. I've got a lot of the blue. I'm sort of running out of black. Then you do start print. It's warning me that if you've didn't take your previous print off, you're going to have a bad time. Then it goes into the detail mode. I can hear it, obviously, and the printer is coming to life. It's going to heat everything up. This takes quite a bit of time. It does a lot of auto leveling. I think I need to maybe go in there and configure it to not have to auto level every time. But yeah, it does quite a bit of a wind up, maybe up several minutes. And then the estimated printing time will be pretty accurate after that. So I'll be back when it gets started. Technology is crazy. It's going to town in there. Creality's default auto layout was stupid, but I chose the second most stupid one, which is printing it on the short part, the shortest piece of the L bracket on the bed, instead of the longest one with the 2 screws, but whatever. There it goes. It says it'll take about 20 minutes. Looks like a pretty sweet L bracket to me. Look at that. This direction is perfect. The screw holes line up. The holes are too small. I think that's the only problem I'm seeing so far. Nailed it with this one, but that had way less tolerance, obviously. I don't have the screws I need yet. They should hopefully show up tomorrow. But as a test fit, I've got one of these standoffs that is the right size. And yeah, it does not fit through these holes. So I'll have to thread it in, which I guess you could argue is better. I'm gonna print. I'm feeling confident. I just scraped the crap out of it. I'm feeling confident enough that I'm gonna print 4 more, but I'm gonna make the diameter of those holes just slightly bigger. I think we'll be good to go. I think I got the screw situation figured out. So I bought a kit on Amazon with a bunch of M3 screws. These are 5mm screws by default, just, you know, screwing it into a PC. The kit has M3 by 8mm, which should make up for our 3mm L bracket. Got 2 printed so far. There's another one cooking, so hopefully you can't hear that. We do have another problem though. This thing is going to have an adapter hanging off the back of it. I guess we have 2 problems. We're going to have to deal with some strain relief, which might require some more 3D printing. But I got a length issue with the whole assembly on there. It hits the back of the wall and can't go all the way, which is fine, but I would also like to be able to have this thing mounted and pull the adapter out. So don't like how that's going to look. It's not the end of the world, but I've got a couple of these adapters. This Unitech one has served me well. I also have this Aluxum. I don't like that it has a backup button. Don't like that one bit. I don't like a lot of things about this one. So the USB cord on the Unitech is just hardwired, which is fine. And this one is whatever that is. Don't lose that. Let's tear this one apart and see if we can make it not as long. One is clearly a knockoff of the other, and in turn probably a knockoff of something else. But it looks like if we get under here, yep, there are some screws in there. Not much to it. This is the side I need, SATA connector. So I want to keep this guy alive for IDE and SATA. It's a useful device to have, but I haven't tested this one. We'll do it before I make any modifications. But we can shave a significant amount by desoldering this IDE header, because I don't need it for this one. Then we could, if I really wanted, I could probably save a lot more by just chopping this board down here, because all it's doing is connecting the 2 IDE headers together. The SATA stuff is like totally separate. I think we're going to take this IDE header off. First, let's test it, make sure it even works. It does work. Just tested it, and I've got 3 brackets printed so far. So let's desolder this thing. I don't think it's a good candidate for the desoldering iron, because it's essentially surface mount on both sides. So I think we'll just hit it with more solder, flux, desoldering braid, and see where we get. As you can imagine, that was pretty tedious without a hot air station. I had to clip a couple pins, then I came in and cleaned it up. I just tested it. It's still working. So let's see if it made any difference. Yep. Chloe cat hair everywhere. So that's with it hitting, literally hitting the wall. So I can pull it out a little bit. Maybe just have the black bezel sticking out like that. Yeah, I think that's going to look good. Like I said, nothing is practical about what I'm doing here. But I imagine eventually I could make like a rail system, and I could slide the whole thing out and then pop this out whenever I needed to use it. But I have the other one. I have half a mind to Dremel this bad boy. I'm pretty sure we could cut off another ½ inch and not impact any of the SATA behavior, because these are just interconnected to this other IDE style header with some other stuff. So as long as I cleanly cut it, there's nothing crossing over or anything. I'll probably throw some Kapton tape on there so nothing hits it. I guess I don't know what it looks like in the case, do I? Yeah, we get the same amount of clearance, so this little connector's off the edge now. Maybe I'll Kapton tape that and then put it fully back in its case just to be a good citizen down here. Nice, yeah. I would say we shaved off quite a bit. The screws came, the brackets are on. I did have to do a little tweaking, but it wasn't that big of a deal. It's almost over-engineered. I don't even think I needed both screws on each bracket. Very strong. Let's see what it looks like. Doing a little test fit here. I have the black bezel proud of the shelf because I think that's going to give me enough room to take off the adapter. The adapter's on there. Yeah, I can just barely get it off. Let's see if that works with the case on this adapter. No luck. With the case on there, it adds an ever so slight amount of extra length. Let's see. I could shave this off, but I don't have a good tool to do that aside from a hacksaw. I'm not sure I feel like dealing with that at the moment. I think I'll just leave the case off. It's only 12 volts in there. And I'm probably either going to shave this one down dramatically or find a smaller one. So that won't be too big of a deal. What I'm going to do is design another 3D printed part that overlaps with this and connects somehow. Kind of goes down in here and supports the back of this board. It doesn't necessarily need to connect to this board. I do have a screw right here that I can use as a mounting point. Unfortunately, I'll have to find a longer version of whatever that is. Hopefully I have one. But there's another M3 hole right here, and I've got plenty of those now. I'm going to draw this out, take some measurements, and we'll see what I can cook up. This is going to be a little more advanced because I'll mount the plate here, but then it needs to lower down, so I'll have to extrude this way for this portion. And this is a high point, this is a high point. You don't want to be too inaccurate for this since it is a actual connector to an electronic part, so I'll be back. Got all my measurements. I'm not going to do any fancy angles or anything like that. We'll just do right angles everywhere. And then this portion here will be extruded, hopefully in the right direction, to support the board with this space right here. Let's go build this. My thinking is, in order to learn how to do this, I've just created a rectangle and I've extruded it the 3 millimeters. So this is one little plate, and I'm going to attempt to extrude part of it the other direction. I don't really know where to begin. I guess I need to do a sketch on this plane. Bear with me. Let's just draw. Can we just draw another rectangle? We can. Okay. Let's try to extrude that one. We can. What's happening? Oh, we've done it. So in my case, it's going to be something like that. Okay, I have the basic idea. That was going to be the hard part. So everything else is going to be like what we've already done together. And I didn't measure the holes yet. That's a classic move I seem to be doing. I'm going to build this to the right dimensions, and then I'll be back. Got the basic shape down. So this is the edge of the DVD-ROM at the top there. And then the part hanging off is going to be the support, and I need to extrude this. It's hard to show you. So now I think I'm going to make another sketch on this plane, another rectangle like that, and then we'll try extruding this thing. Yes, okay. I only need it to be about 7 millimeters. Yeah, that's the part. It's going to be tricky to get the screw holes right because I have this piece overhanging the drive a little bit, I'm going to go figure that out, and I'll punch the holes through here. Something like this. Looks a little wild, but we have a screw in the upper right and a screw in the bottom left. And they clearly built this with the metric system, because anytime you measure from a sharp edge of the device to a screw hole, it's an even millimeter number, like 90. Okay, I didn't double check any measurements, but it's good enough to try. We've got the two screw holes, and it recesses down to support the device on the back. I'm going to print this out, and we'll see how we did. Doing a test fit, and I am liking what I'm seeing. The screw holes line up. I'm feeling very powerful right now. Feel like I could make anything. One thing to note about this is it is an outrageous waste of PLA. So I could have had the 3mm just going off like this, and then done a few posts to contact this. I knew that. I'm learning. I'm just trying to make anything work. Of course, it doesn't fill larger parts with full PLA. It's doing some sort of support structure here, but it's still a waste. And so far, so good. PLA, by the way, stands for polylactic acid, and it is the pretty typical filament material you would use to 3D print some stuff. I've always used these Hatchbox PLA spools I bought on Amazon years ago. That's what this blue one is as well. Been working fine for me. It's not perfect, so when it's on there, I think it is applying maybe a little too much pressure. We're upside down, so some cords are going to be coming out and applying strain this way, which is what we're trying to fight against. I think it's going to be okay. It's going to look something like this when it's, imagine the shelf is here. So we have all these cables coming off, and there's a little bit of play, but definitely not enough to be a problem. I made sure to make it shorter than this board because I don't have a lot of room back there. So if this is screwed in, I will be able to pull this out while this is in there. I don't know if I'll ever need to do that. I'm also probably going to rebuild this whole thing someday, but it was a good excuse to learn how to 3D print, and I think it's going pretty well so far. 3mm is not enough for an M3 screw. You think I would have learned my lesson after installing 8 of them, but we can fix that. I'm trying to get that M3 screw started, and I can't find the Torx bit that I was just using. I've only lost one of these bits somehow. It's here somewhere. Is it this one? It's not that one. No, not like this. I found it. It was in the case the whole time. So apparently I've lost 2 of them. Luckily one of them is not this one. You could almost do it with just the one screw. I was kind of wondering about that. And I'm really curious if the original screw here has enough length to get in there and bite. Obviously, it does not. Okay. This was a situation where I could have beveled that down. I don't know if that's the right word. Anyway, made it lower so it would fit. Found one that worked well enough. It got in there, and it is solid. Looks suspiciously like a compact drive sled screw. And here is the ridiculous contraption we have made. That slides in. Has a little bit of strain relief. I made this a little too deep, so I think I should have not come up as much, but I don't think in practice it's going to be much of a problem. So yeah, get into 3D printing and you too can have one of these. So I just put my rubber bumpers on there, and I drilled a hole in each of them to help the screw get started. I don't think it's strictly necessary for the functionality here, and I am now realizing it's going to drop it off the shelf a little bit by roughly the depth of the rubber bumper. I'm worried about noise, so this thing is spinning and it's vibrating into the shelf, into the wall, into the other shelves, and all the stuff that's on the shelves, and I just don't want to listen to that. So I'm hoping this makes a difference. I don't think it's, like I was saying, I don't think it's required for this thing to function, properly. Obviously, this would be bolted in pretty solid to a PC, and of course I've just been using it loose on the desk the last 3 years. Let's get this thing installed. This is going to be so good. I tested that I can indeed get the adapter out. Again, I don't know if I'd ever need to do that, but it's a nice option to have. These guys are clamping the front 2 brackets. It's roughly where I want it. I'm going to put the back 2 brackets in, then I'll be able to take one of these clamps off, and it should stay pretty positioned. I have found with these wood screws and this, what is it called? Common board, it's better to just do it by hand. The drill gets in the way, the impact driver destroys these wood screws, so yeah, I'm going to screw these in by hand. I cannot stress to you enough how exciting this is. This is really good. Got 3 out of 4 in, so I'll put this one in now. Oh yeah. I have good news and bad news. It looks great. However, my machine can no longer detect the adapter. We should have heard a little chime from Windows. It doesn't see it anymore. I think the problem is that little bit of deflection that is in my 3D printed part pushing the board. I think. The good news is I can actually take all that stuff out without having to mess with this again. So I can move the speaker out of the way. I can unscrew that massive part we just made. And then I'll try turning it back on even with some strain on the cables and see if it detects it. That was the problem. The strain relief bracket, I loosened it just a little bit. It's still on there. Listen to this. Okay, that was a little bit of a fail. We can, again, I'm probably going to redo this whole thing, but good enough. It was something to do with this screw. So if I leave that really loose, essentially not in there, everything's fine. But the M3 screw can be torqued down no problem, and so that's providing all the strain relief. If you're wondering where I'm plugging in the USB cord, it's going into this, my 12-port patch panel situation. The main workstation is actually on the other side of the wall, and I've got this big USB hub, and there's the keystone panel. I'm actually pretty proud of this setup. It's one of the smarter ideas I've ever had down here, as ridiculous as it looks. I'm really happy with this. I can come here, burn a disk. It's going to be on all the time. It's permanent now. I don't have to fiddle with cables. Let's figure out the floppy drive. This won't be a rinse and repeat of the DVD-ROM because the requirements are different. I don't want this permanently mounted. I want to be able to slide one of these in to like a shelf, a little bracket or something, because I like to pull this out and test other drives with the Greaseweazle. So 2 requirements. The ability to have this in there, easy to use the floppy, pull it out when I want, unhook it from the front, and also be able to easily get the Greaseweazle somewhere else because there are other floppy drives other than this form factor I need to hook that thing up to occasionally. So I have been thinking about this all day. Just got off work and I'm not sure what I'm going to do. I have some ideas. I'm going to experiment. This is what I cooked up. It's a little weird. Also, I have a lot to learn. I was able to do this with the simple techniques you've seen so far, but clearly there are more efficient ways to accomplish this. This guy was particularly tricky. I had to learn about making him incident to something else, which I am not smart enough to explain to you. That's my weird part. I decided the tray on the back, the Greaseweazle isn't heavy enough. The brackets here should be strong enough. I'm going to double check my measurements on this one, and I think we're going to have to build some supports in the slicer because I'm going to print it this way down on the bed, so it'll start with the bottom, build its way up. That'll all be straightforward. But obviously, the printer isn't going to be able to cut over like this. So it's going to have to build up some support, and I don't think I can print it like this way. Yeah, I'm just going to do supports on the brackets. Let's see what Creality thinks of that. Uh-oh, it's too big. It doesn't fit on my plate. I can fit it that way. I got to shave off just a little bit here. That's no big deal. I kind of made that longer than it needed to be. I mean, maybe it's no big deal. Let's see how we can do that. So I think that was my very first sketch. Yes. This guy is going to save us maybe. Let's make it 130. I think that's okay. Yeah, let's export that. It's certainly happy to print it standing up. I wonder if that's a reasonable way to do it. I doubt it. I don't know. I don't know what I'm doing. It also seems to think it can print it this way. Oh, that's not what I want. The software thinks it can handle that. Yeah, so I'm not surprised by this. When I try to slice it, it says, yeah, you've got these things hanging off. We're not going to be able to print those. There is somewhere I can enable supports. This option right here, we can come down to support. I'm going to enable support, and it doesn't show it to me. Maybe I got to slice. Yeah, there we go. It's going to build some serious supports for that thing. They usually just snap off. They're not as strong as the rest of the piece. You can also make little trees or something. Yeah, there it is, tree. Slice. So these are like really creepy looking. But just for fun, I'm going to do those because they're just so bizarre. Oh, and then I'm still going beyond my plate boundaries. Why didn't it tell me that again earlier? Shaved a little more off. I think we'll be okay. Seems to be happy with it. It's going to build these creepy little trees. Says it's going to take 3.5 hours, so I'm going to send it to the printer. And we'll do blue. I have built this thing. The thinking behind it is the Greaseweazle's floating around somewhere back here. I can slide a drive in, and notice how it gets stuck. That's what this little notch was for. Slide a drive in, doesn't go any further. And then from the front, if this is mounted down, push on it, no problem. Floppies come out, no problem. It's not getting stuck in the back. I think in practice this won't be as clean as I was hoping. Let me get this hooked up here. These cables aren't going to work out, so I'll have to buy some different ones. But an important aspect is I want to be able to pull this all the way out, unhook it from the front. When this one inevitably goes bad, or I want to try another drive, push it back in. It's kind of working, but that does lead to a cabling issue. I think I can have it like this. That might work better. Remember, there's like a shelf here holding all the stuff down. I've got these janky little adapters to make a long enough power cable. So what I should do is buy a long, flexible floppy power cable and a long, flexible floppy cable. I'm saying flexible. I don't know if they make these, but hopefully. Or train one to go in and out like that. Anyway, I don't want to mess with this one. I could pull these off, but it's nice to have this older style connector for older drives. That is why it's actually on the Greaseweazle right now. So, and then it was going to be tempting to put these in exactly the same spot as the CD-ROM, but I was smart enough to offset them. So the drive it's going to be next to is something like this. And so it can butt up nice and close. So I did think of that ahead of time. Let's try a test fit. It's not the best design and it doesn't look like much, but let me tell you, that is going to be really nice to have sitting right there. So I'm going to screw this thing in and we'll see if I can actually, I didn't think about this. Yeah, I can kind of pull it out. Alright, the Greaseweazle is back there. It's not pretty putting these cables in and out. This is my first time trying it, and I can already tell it's going to suck. But that's okay. I just don't want the cables pushing the floppy drive out. Oh, and they don't. Yeah, that's plenty good. Everything's sort of just jammed back in there, but that's okay. We can use the floppy drive just fine. We'll see if it works. Greaseweazle ships with a program called GW. Mine's in a folder called Greasy, because I thought that was funny when I set it up. GW info. It's plugged into the USB now. And it sees it. So I'm going to do GW erase. Let's try erasing that Windows 95 floppy. There is no guarantee the cables didn't fall out as I did that, so I'm going to press enter. Yeah, the power cables definitely fell out. It's not doing anything. Actually, I was using a USB-C cable it did not like for some reason, so it's hanging there. Nothing was actually unplugged. Everything was cool. Repositioned back in there. Let's erase this thing. There it goes. Success. We erased that disk. No notes. This is great. Accidentally got lucky. The USB port of the Greaseweazle is right here, so it's very easy for me to get to it. In my current setup, the USB and the Greaseweazle are actually powering the floppy drive. So it's actually nice to be able to pull out a floppy drive, put it back in. I guess I could pull it from the wall over there, but either way, it's nice to be able to access the one thing I need. Well, here's the new physical media command center. I'm going to get a lot of use out of these two brackets. There is one more thing I want to mention before we wrap up, and that's a free and open source CAD tool called OpenSCAD or OpenSCAD. The difference with this one is you create your models with scripting, a programming language. And as we all know, there's something out there that's pretty good at producing code. Whether it's right or not is a different question. Yes, LLMs. So I've read a bunch of articles that you can basically describe the bracket in text, maybe even give it your picture, and it will produce the code that OpenSCAD, I'm not really sure how to pronounce it, understands, and it will produce your model. Now, that's a pretty interesting proposition. I know a lot of people are very morally and for other reasons opposed to LLMs, but they're a tool like any other, and unfortunately or fortunately, they're here to stay, however you look at it. I will try that eventually, but I wanted to learn how to at least get the basics first. In fact, I think I'll try it out of curiosity. Now that I've designed a few parts, I can't imagine I would ever actually just throw it at an LLM because it's kind of cathartic. The more I was doing it, the more I enjoyed it. It was pretty surprising. And it's really important, I think, to realize that folks like developers that are seeing a lot of success with LLMs, the ones that are having the most success are already excellent developers. They've been developing for 10 plus years, multiple years, pretty large careers. Those are the people that are having a lot of success with these things because they already know the answer and they just have the LLM do it for them. Now, there's some exploratory stuff. I don't really want to get into it here. It's a big topic. I guess what I'm trying to say is it's important, I think, if you're going to do something in the long term, to understand the basics and get in there, get your hands dirty, do it yourself. Now, on the topic of 3D printing, I am pleasantly surprised. I thought it was going to be really hard. I wouldn't say it's easy, but now having done it, I can confidently say anyone could do it. If you have a 3D printer, you can design your own part. I'll link down to 2 useful YouTube videos that I watched, and that was basically the extent of my research for what we dove into. In the past, I've watched a lot of like how to 3D print videos, and like I was saying, they make it way too complicated. A lot of you that are experts at 3D printing are going to cringe of all this screen recording I did of me trying to make these parts. I'm just drawing lines together, but who cares? Look where I am. I'm just trying to produce something that's useful for me. I think that's sort of the ethos of 3D printing. You're disconnected from these large engineering firms and factories that would usually have to make you an L bracket. I spent about an hour and I had an L bracket that worked, and now I've got my ridiculous setup over here that I'll probably redo. This video was a little different from the norm, but I hope you enjoyed it. I needed an excuse to learn this stuff. I've been wanting to learn how to design a part to 3D print for many, many years, and I kind of took little baby steps, downloaded some sort of free version of AutoCAD they had back in the day. Never really got anywhere with it, and so I gave myself a goal. An L bracket is a pretty good starting point, I think. You got to at least do one angle and some holes, and sat down and said, I'm just going to figure it out. I'm just going to bash away at this tool until it works. And it wasn't that bad. I would encourage you to try it. But that's going to do it for this one. I am on the road to 100,000 subscribers this year, which is a statistical anomaly. However, I know almost 40% of you are not subscribed. If you'd really like to support the channel, it would mean a lot to me if you subscribed. And I'm also on Patreon. I post behind the scenes type videos, early release videos with no ads, and you also get access to the Serialport Discord, where myself and a bunch of other great folks hang out all the time. That's it for this one. Go 3D print something. I'll catch you in the next video.